This table summarizes the basic arithmetic operators available to us in Java. All of these are binary operators, which simply means that they take two operands, one on each side. All of these are used to perform numeric calculations. These first four operators should look very familiar. They are the typical big four operators of any basic math: addition, subtraction, multiplication, and division. There is one new operator in this list you may not be familiar with, and that's this modulus operator, represented by the percent sign. The modulus operator is used to calculate the remainder after doing integer division. We'll come back to this one shortly. Let's first take a look at some examples involving the basic four arithmetic operators. Please take a moment now to pause this video and view the short code walkthrough video for operators arithmetic.java. Go ahead and open up this file in JGrasp also so you can follow along. As always, this Java file can be found in the example source code module on Canvas. Come back to this video when you're finished. In the code examples we just went over, we saw an example using the divide operator to do traditional decimal point division. Well, it turns out that Java also supports a different mode of division, which is integer division, and this is where the modulus operator comes in. For example, now in integer division, as we see here, 18 divided by 16 is not 1.125. Instead, it's just integer 1, a whole numbered result. The modulus operator is now its companion operation, and it gives the remainder left over after doing that integer division. So 18 mod 16 is 2, the remainder after that integer division. These two operators taken together have lots of practical utility. For example, is a number even or odd, or evenly divisible by some other integer? How many whole numbers of something can fill a container? And how many will be left over? How many whole numbers of something are there per some unit of time? These two companion numerical operations are exactly what you did a little while back in performing all those number system conversions. Remember? Let's take a look at some more examples. Here's another example of integer division in modulus. Suppose we declare and initialize these two integer quantities, a and b, as shown. Now, when both operands are ints, we're doing integer division and not floating point division. So we're going to get an integer, or in other words, a whole numbered result. In integer division, the result is just the traditional quotient if we had tried to work this out by hand. The modulus operator gives us the integer remainder for the same problem. These two operators and this idea of integer division always seems to trip students up if they haven't seen it before. So let's take a look at a few code examples. Please take a moment now to pause this video and view the short code walkthrough video for operators integer division.java. Go ahead and open up this file in JGrasp also so you can follow along. As always, this Java file can be found in the example source code module on Canvas. Come back to this video when you are finished. Java also provides two shortcut operators, the ++ and -— operators. Notice that both these symbols together constitute one operator and that there's no space between their two characters. The shortcut operators are simply a useful shorthand to increment or decrement a single variable by 1, as shown here. This is such a common operation in programming that it warrants its own special shortcut. Both of these are unary operators, which means that they are applied to one single variable argument, as shown here. There are also prefix and postfix versions of each operator, which has to do with the order in which these operators perform their instructions. In the prefix versions, the variable is first updated, then the updated variable is used in any surrounding expression it's part of. For the postfix version, the opposite is true. First, we would use the variable in any surrounding expression, then its value would be updated. It's probably best to see some examples of this. Let's take a look at the example file listed. Please take a moment now to pause this video and view the short code walkthrough video for operators shortcut.java. Go ahead and open up this file in JGrasp so you can follow along. As always, this Java file can be found in the example source code module on Canvas. Come back to this video when you are finished. The shortcut operators we just saw represent the special cases of adding or subtracting 1 to or from a variable. Java also provides a fuller set of more general shortcut operators as summarized in this table. Again, there is no space in between the two symbols of each operator. Together they constitute one operator with the equal sign always coming second. Also, now each of these operators is a binary operator, so you'll always have the variable name on the left and the increment value on the right. So all of these statements in the middle column are programming shortcuts for the equivalent statements in the right column. Note that all of these are standalone statements as evidenced by the terminating semicolons. In all cases for these middle column shortcuts, the left-hand side variable a has its value updated by the right-hand side value. For example, the statement a plus equals 3 is just a shortcut for the equivalent statement a equals a plus 3. Once again, let's take a look at the example file listed. Please take a moment now to pause this video and view the short code walkthrough video for operators arithmetic shortcut.java. Open up this file in JGrasp so you can follow along. You'll find this example in the example source code module on Canvas. Come back to this video when you are finished. Finally, I want to leave you with the idea that these operators we have in Java are by no means unique to Java, but rather are common across many other programming languages. I said previously that if you put in the effort to learn these things well in Java, they'll feel very familiar in your next programming language. Well, here's some more evidence of that. Across the top again, we have some other languages that we teach here at the college. Down the left, we have a summary list of all the operators we've just covered, and in this first column, their syntax in Java. Once again, if you take a good hard look, you'll see that all of these operators are dead identical in these first 4 languages. Even for VB.NET, most of the operators are still the same. So in closing, focus on the concepts of these operators and how they work in Java, because the ideas and the details are no different in many other languages. Learn them once in Java, and then the other languages will be that much easier.